So today we're going to do another lesson in Unit 2. This is going to be on properties of functions. Again, we're going to do a lot of graphing again today, and we'll probably look a little bit more of how to use the graphing calculator as we move forward. So, like I said, in this assignment, the graphs of functions will be continuing to be studied. One of our goals is to identify what's called an increasing and decreasing intervals, and also what's called a constant interval. We want to be able to identify local maxima and local minima. And we want to be able to determine the absolute maximum and the absolute minimum. We also wanted to be able to determine if a function is even or odd, and how symmetry is identified here. So as we move forward, then let's first talk about increasing and decreasing intervals. So in identifying if an interval is increasing or decreasing, what we do is we track the x values from left to right on the graph. So we start at the far left and we move our way to the right. If the y values are increasing, then it is said that the function is increasing in this interval. If the y values are decreasing, then the function is said to be decreasing. If the y values remain the same, then the function is said to be constant. So as I move forward here, notice how we move starting at the far left. Notice as I start to track, notice how the graph, the y values are going down. So that's described as decreasing. I'm just going to do DEC for decreasing. So notice that from -10 to -8, the y values are decreasing. But once I get to this -8, notice how the graph turns, and now it's going in an upward direction. It's going upward again. It stays upward until I get to this -2. It starts to turn again. So from -4 to -2, the graph is going in an upward motion. That's described as increasing. So I'm going to use it like an INC there. So that's increasing. Notice how it turns again. And from -2 down to 0, the graph is going in a downward motion. So again, that's what we call decreasing. Notice how it turns again, and it goes in an upward motion again. So from 0 to 2, that's described as increasing. And notice how it turns again, and it goes down. And so now it's going in a downward motion, so that's decreasing. So notice that from 2 to 5, that is decreasing. And then from 5 to 7, notice how again it's going in an upward motion, and that's considered increasing. So increasing, again, as you move from left to right, if the graph is going in a downward direction, that's considered decreasing. And then if it's moving from left to right and the graph is moving in an upward trajectory, then we call that an increasing interval. So let's look at some of these questions here. Is f increasing or decreasing on the interval -8 to -2? So again, what they're referring to is the x values. So we're looking at a left to right direction. So as we move from left to right, is the graph going up or down? So -8 is over here at this spot. So at this spot here. And as we go up to -2, notice how the graph was going in an upward trajectory. So is f increasing? We would say, well, yeah, it is increasing there. Is f decreasing on the interval from 5 to 7? So again, we're looking at the x values from 5 to 7. So notice how here is the 5, and here's the 7 here. Is the graph going from left to right? Is it increasing or decreasing? Notice how it's going in an upward trajectory. That would actually be no. So it is not decreasing there, it's actually increasing. So is f increasing on the interval from 0 to 5? So again, we're talking about the x values here at 0. Here's 0 now. And here is 5 here. Notice that when you go from 0 to 5, it goes up and down. So it's not only increasing, but it's also decreasing. So that would also be false. Is f decreasing on the interval from 2 to 5? So if I start at 2 up here and go down to 5 down here, notice that from 2 to 5, the graph is going in a downward trajectory. So that is decreasing. So that is a yes. So our next question is list intervals on which the function is increasing. And again, I'm going to use interval notation here. So using interval notation, where it's increasing, notice that I have this little INC over here. Notice that that was from -4 to -2. It's increasing. So including -4 up to -2, that is increasing. Now, it's also increasing from 0 to 2 here. Notice that we've got that INC again over here. So from 0 to 2, it's also increasing. So again, using interval notation, that'd be from 0 to 2, it's increasing. And then if I'm looking at 5 to 7, it's also, so from 5 to 7, that's going to be also increasing. So that's what I would think the answer should be there. It would be those 3 intervals. Now the catch is I'm not sure about inclusion or exclusion at this point of those endpoints. But right now my instincts are saying include those endpoints. So if I want to list the intervals on which f is decreasing, notice how now I'm looking at from left to right, I'm looking for where the graph is going in a down direction. So notice how from -10 to -8, that interval, it's decreasing. Also, it's going down from -2 to 0. So -2 to 0, it's also decreasing. And then from, go over here, look, I see another little DEC. So from 2 to 5, it's also decreasing. So that would be the intervals that I'm seeing on this one. So I would think interval notation would be the best way to describe that. So what else do we have here? So the next thing we have is what's called local maxima and local minima. So local minima. Local maxima and minima are what we call interior points in which the graph turns. So in other words, if the graph is increasing and then turns and begins decreasing, the y value is called a local maximum. It will kind of look like a hill, if you will, from a visual. If the graph is decreasing and turns and begins increasing, the y value is called a local minima. It will kind of look like a valley. And again, a graph doesn't necessarily have to have them. So let's look at our graph. Is there a local maxima at x equals -2? If yes, what is it? So let's go where x is -2. So x is -2 right here. Notice that if you're going from left to right, the graph is increasing and then it's decreasing. That kind of makes a hill. So yeah, that would be a local minima. So what is it? It would be the y value, which is 6. So that would be what we call our local maxima. Is there a local minima at x equals 5? So notice how x equals 5, I have a little spot here. Notice how the graph is going down and then turning back around and going up. Notice how that kind of makes a valley. Since that's a valley, yeah, that would be considered a local minima. So this was yes, and it was at 6, and this is going to be yes. And what is the actual local minima? It would be actually the y value, which is the 0. So our next question says, list all the local maxima. Express using the y coordinates. Okay, so if I go from left to right, local maxima, I'm looking for the hills. So that's a valley. So -2 would be a local maxima. I'm turning 0, 0 would be a valley. 210 would be a hill again. And so that would also be a local maxima. That's a high point. Then I have this turn again, and there aren't any other interior points. So look, let's list all the local minima expressing using the y coordinates. So minima means we're looking for those values. So notice how it's decreasing, then turning and increasing. So over here, -4 would be a local minima, since we're talking about the y values. So when x is -8, the local minima would be -4. That's the low point on the graph. Notice how it turns, and then 0, 0 again would be a low point again. That's a valley. So the y value there would be 0, so that would be a local minima there. And then the 210 was a high point. The 5, 0 again was a low point. So again, we're just getting that 0 again. So -4 and 0 are our only minima in this case. So another thing we're going to be talking about is what's called an absolute maximum and an absolute minimum. An absolute maximum will be the highest y value on the graph of the function, and the absolute minimum will be the lowest value of the function, the lowest y value of the function. Again, a function doesn't have to always have an absolute maximum and or a minimum, so it just depends on the graph. So for the absolute maximum, if I want to find the absolute maximum, looks like this is the highest point on the graph. So that y value there would be 10. So that would be our absolute maximum. And the absolute minimum would be the lowest point on the graph. And I'm seeing this over here as my lowest point. So -4 would be what's considered the absolute minimum. It's the lowest point on the graph. So that's what I mean by absolute maximums and absolute minimums. So another thing we're getting into is even and odd functions. So some graphs are going to be described as even functions. The thing about even functions is they're going to be symmetric with respect to the y-axis. Remember, being symmetric to the y-axis means the graph is kind of mirrored across the y-axis. We also kind of said, you know, if you put f of -x in to the function, that should give me the same thing as f of x. So that's going to be a way we're going to be able to determine this algebraically. We'll talk more about this here in a little bit. Some functions are going to be described as odd functions. Odd functions are going to be symmetric to the origin. Remember how we kind of said if you rotate the graph upside down, it should look the same. Or in other words, there should be a point reflected across the origin on the other, like if there's a point in the first quadrant, there should be a point in the third quadrant that kind of mirrors it. So let's look at this problem here and see what are the kind of questions that we can get into. So we want to find the x and y intercepts here. So the x-intercepts are where the graph crosses the x-axis. So what I'm seeing here is -2, 0 and 2, 0. So as ordered pairs, -2, 0 and 2, 0 would be my x-intercepts. So sometimes they just write the letter and sometimes they write them as ordered pairs. The y-intercept is where it crosses the y-axis. So here's the y-axis here. And I do see the graph crossing here at this spot right here. So the y-intercept would be 0, 3. So that ordered pair there, or simply 3 would be the y-intercept. Let me get rid of these little marks again. So the next thing is determine the domain and range of each function. So as far as the domain goes, I'm just going to use letter D for that. Using interval notation, the domain is your left boundaries and your right boundaries. So if I move to the far left, -4, 2 is my farthest point to the left. If I move to the right, my farthest point to the right is that 4, 2. Now remember, domain is the x values. So the left bound would be then the -4 up to then the 4. So that would be the interval of that graph. The range is going to be the lower bound and the upper bound. So the lowest y value I see is here and here, so they're really the same. And the highest graph point I see is this 0, 3. So looks like the graph is in between those two boundaries. So as far as the range goes, the lower bound was the 0 and the upper bound was a 3. So my range using interval notation would look like that. So our next question says, find the intervals in which the function is increasing. So again, when we talk about this, we're talking about the domain. This is a domain question. So what I'm looking for is where the graph is going in an upward direction. So if I start from left to right, notice how the graph is going down, but here the graph is going in an upward trajectory. So again, from -2 to 0 would be, and again, I usually like these brackets there. So let me erase that. I can't remember which one it is now, but for some reason, I don't see a reason why we can't call it a -2 to a 0, including those points. And then the graph turns and goes down, but then notice how again, from 2 to 4, it's going up again. So where it's increasing at would be also from like 2 to 4. So that would be the intervals that I'm seeing. Okay. So which intervals is the function decreasing? So decreasing is when the graph is going in a downward direction. So again, we're talking about domain. So again, from -4 to -2, the graph is going in a downward direction. And then it's going up again, but then notice how between 0,3 and 2,0, it's going down again. Again, I'm using just the domain values. So the boundaries there of the interval would be 0 to 2. Now, that would be the intervals that it's decreasing. Is the function even, odd, or neither? What happened here? Go away. Let's see here. All right. Is the function even, odd, or neither? So remember, even means it's got to be symmetric with respect to the y-axis. So notice how there's this y-axis here. It looks like the graph is mirrored across the y-axis. So that means this is an even function. So yeah, it is even. So look at this next graph. It looks like we have now find the values, if any, at which f has a local maxima. So again, I'm looking for the numbers, if any, at which f has a local maximum. So we're looking for the x values here. What x values create the local maximum? So again, a maxima is a interior point that's got to be high. So what I'm seeing here is there's a local maxima at 0. So again, what are the local maximas? That's the y values. So that would be the 3. So find the numbers, if any, where there's a local minimum. So notice how there's a valley here at 2, 0, and there's a valley over here at 2, 0. So -2, 0, and 2, 0. So the x values there would be a -2 and a 2 would be the values at which there is a local minima. And what is the local minima? That would be the y value, which of course, both of them give you the same one, which would be 0. Again, is this function even, odd, or neither? Notice how, again, this is the y-axis. Notice how the graph is reflected across the y-axis. Even functions do that. So again, this is going to be an example of an even. So now we move into away from graphing and do a little bit of algebra here. Determine if the following function is even, odd, or neither. So for even, we're going to use f of -x equals f of x. So if the degree of each term is even, then the function is even also. That was another thing you look at. For odd, we're going to use f of -x equals the opposite of f of x. So if each term is odd, then the function is odd. So if I look at number 1, notice that the degree of this is odd. So my guess right now is this is probably going to be an odd function. But to verify this, we have to find f of -x. So to find f of -x, what that means is replace x with -x. So what that means is you have a -x to the third Well, what that becomes then is a -2, and a negative times a negative times a negative is still a negative. So it's really just going to become negative x to the third. And we know that a negative times a negative is actually a positive, so it's going to be a 2x to the third. Now to do negative f of x, so I got to do f of negative x, and we also have to use negative f of x. To do negative f of x, that means to take the opposite of that function. So that's going to be the opposite of negative 2x to the third. Well, the opposite of a negative is actually a positive. So notice how we get the same thing. Since f of negative x is the same thing as f of x, that means this is an odd function. Also notice that the degrees was a 3, so that means it's odd as well. Looking at b, is b even or odd or neither? But notice how the exponents are even, so the chances are this is not going to be odd. Notice how this is a degree 2, this is a degree, I'm sorry, x to the fourth is a degree 4. Negative 2x squared is a degree 2. And remember, 4x has got this 4x to 0 on the end, so it's actually a degree 0. Since all the exponents are even, this should be an even function. What they also say is if I use f of negative x, I should get the same thing as f of x. So if I use f of negative x, I got to get the exact same thing. So if I put negative x in for each one, so I have negative 2x. So I got to replace the x with the negative x, like that. And remember, if a negative is raised to an even power, if there's an even number of negatives, that just still makes it positive. So it's going to be x to the fourth. And notice how, again, negative x squared, since there's an even number of negatives, that's going to be a positive as well. So it's still going to be negative 2x squared plus 4. Notice that f of negative x is the same thing as the original. So yeah, that would be even. Actually, I was supposed to use g of x here, g of negative x. Let me get my little eraser out because I actually changed the function. It's not a f there, it's a g. So I'm actually evaluating g of negative x since the given function was g. So this next one, I'm not really sure what to do with this one because it's got a cube root and then this 5x squared inside there. So what I'm going to do is evaluate h of negative x to start with. So it's going to be the cube root of, and then you're going to have inside here 5 times negative x squared plus 2. And remember, a negative times a negative is still positive. So notice how I get the same function. I get 5x squared plus 2. So since h of negative x is the same thing as h of x, that means this is an even function. On this one here, notice how I've got a degree 3 and a degree 0. This is probably going to be neither. But let's just go ahead and verify it. If I do f of negative x, I get 3x, 3 to the negative x to the third, plus 7. And remember, when you have a negative raised to the third power, it's still going to be negative. So it's just going to turn into a negative 3x to the third, plus 7. So notice how f of negative x is not the same thing as f of x. So even, no, it's not. The other thing is you have to do negative f of x. And that's got to be the same thing as f of negative x. So if I do negative, that means to take the opposite of 3x to the third plus 7. That's going to give me negative 3x to the third minus 7. Notice how that is not the same thing as this here. So f of negative x is not the same thing as negative f of x. So odd, no. So this is going to be neither. So let's look at some more practice here and see what we can come up with. For each graph of y equals f of x here, so we have this graph over here, find the absolute maxima if it exists. So that's maxima means the highest point on the graph, the highest y value. So notice how 7 would be our absolute maximum. The absolute minimum would be the lowest point on the graph. So it's going to be down here. And that's going to be, the y value would be a 2. So that's going to be a 2. So sometimes I write that, when f is 1, when the input is, or the domain is 1, the absolute maxima would be 7. And when the x value is 2, when the x value is 7, so when the x value is 7, the absolute minimum was 2. So sometimes they might write it like that. So if I want to find any local maxima, I'm looking for hills. So it looks like there's one here. So it looks like there's a local maxima at 5. If I would look for a local minima would be a low point, a valley. I do see a valley over here. So the local minima would be a 2. So kind of, because locals have to be kind of interior points there. So if you look at this graph here, find the absolute maxima if it exists. So again, the absolute maximum means the highest point on the graph. So we have this spot over here at 2, 4. So, 4 would be the absolute maxima. And sometimes they might write it as when x is 2, the absolute maxima is 4. The absolute minima is going to be the lowest point on the graph. But notice on this one right here, the graph has this arrow on it, which means it's going down forever. So this does not have a low bound. So this does not have one. So it has none. There's not an absolute minimum because that arrow means it's going down forever. So there's not a lower bound. So therefore, there's not an absolute minimum. If I'm looking for a local maxima, I'm looking for a turn that's a hill. So 2, 4. So again, 4 would be a local maxima. So if we could say, when x is 2, the absolute or the local maxima is 4. The local minima is looking for a valley. This would be a valley here. So again, the local minima would be 2, or when x value is 0, the local minima would be 2. So that's kind of how we identify that. So sometimes again, we use the graphing calculator. The graphing calculator has several tools that can be used to do some things here. So some of the graphing tools we're going to look at is the window. We're going to play with the x min and x max of the window. We're going to play with the y min and y max of the window to see if we need to see a better graph. So there's also what's called a maxima button that helps us locate local maximas, and we can round the answers to 2 decimal places. And to use the local maxima tool, we're going to be able to use directional adds, arrows to move to the left of the point and make a left bound, and then move to the right of the point to make a right boundary. And same thing kind of for the minimum. Okay, so what does that all mean? Well, here's a function f of x equals this x cubed minus this 3x squared plus 5. And notice how I've got this interval, -2 to 2. That's going to be my x min and my x max. So to put this in the calculator, start with, we use that y equals button. So see if I can get my calculator back out here. Let's see if I can get that going for us. All right. So we got to quit that, looks like. So to use my calculator, let's see if we can get this all up here. Let's see if we get this together. So to put our equation in, instead of using f of x, we use the y equals button over here. So we hit the y equals, and then we got to clear ours off from last time we did something. So x cubed. So to do x, we use the x that's right next to that green alpha key. So if you notice how that lights up red there, that's the x key. To do cubed, there's a couple places to do it. I'm going to just use the up arrow over here and put a 3 in. and then use my right arrow to come back down. And then we have a minus, and then we have a 3. We have then X, and then we need a square. The square key is over here, just kind of diagonal of the 7. And then we have plus 5. So there's my equation. So what we want to do here is we want to see if we can identify some local maxima or minima. And the way we're going to do that is we're going to graph this thing. But first, we're going to change our window to where we're looking at the interval between -2 and 2. So notice how my x min right now is a -10. So notice how at window, we want to change that to a -2. And the, whoops, we got to go back here. Let me try that again. So window -2, I think at the minus sign. Yeah, to 2. Right now, I don't know about the y min and y max. We'll just leave that alone for the time being. So the next thing we want to do is we want to graph it. So we hit the graph button. And it gives us a graph of the function. So notice that between -2 and 2, does it look like there's a local minima or a local maxima? To me, it looks like the graph has more of a hill somewhere in here. So it looks like it's somewhere around maybe in this area here is where the high point is. So let me see if we can kind of find that. So to find the local maxima, since this has a high point between -2 and 2, we're going to use what's called, I think it's under calculate. So if I hit the second button and hit calculate, the fourth one down is the maximum. If I hit enter there, now what I have to do is I have to move kind of left, use my directional pad. I need to move left a little bit to get like on the lower bound. Once I get there, I hit enter. And then I got to move back to the right. And I need to get far enough down where it'll kind of get me where I know that the upper bound where the maximum is in between there. Hit enter. Now it says guess, so I hit enter again and it'll kind of get me there. And so notice how it says the maximum is at 1.4963e to the -6. So in other words, that's actually some type of decimal number or scientific notation. So over here, what this means is you have like one, let me see if I can get my thing to draw here for us. So I've got this 1.49. I'm just going to like leave it at that. But then I got it. This e to the -6 means to move the decimal 6 places to the left. So it's like 1, 2, 3, 4, 5, 6 places to the left. All those places get filled with zeros. 1, 2, 3, 4, 5 zeros. So again, it says round to 2 decimal places. So if I do, we can kind of see that our x value is going to be 0, where our actual maxima is going to be the 5. So when x is 0, the actual maxima would be at 5. So that's kind of how we can do that. That does have a local maxima. Okay. Okay. So let's quit this here. So let's try to put this x function in. Instead of using f of x, we use y equals. I need to clear this off again. This is x to the 4th. So again, I hit the x, which is right next to the alpha key. To do the 4th power, I use the up arrow and do a 4. Got to use my right arrow to come down, minus then this x squared. Okay. Now, again, my window has got to be set between -2 and 2. So under window, I got my -2 and 2, so I'm good there. So then all I got to do is graph my function. So notice how it looks like it has 2 local minima, one over here on the left side of the graph and one over here on the right side of the graph. And those are low points in the graph. They kind of make valleys. So when I go to calculate, hit second calculate, I'm looking for mins. So that's number 3. Hit enter. Now I have to use my arrow key and I have to kind of go left of the lower bound or the local, sorry, left of the local minima. So that looks like I'm getting out of the way. Then if I move right of it, so make sure it goes back up a little bit. That looks pretty good. Hit enter. If I hit enter again, it should give me my my local minima. So to go again, my X value looks like that's going to be about negative 0.71. So if I'm doing decimals, so when X equals about negative 0.71, my local minima would be this negative 0.25. So that would be a min. But also there's another one. So I got to do this again. So if I hit second trace, right above trace has the CAL, that is to calculate. We want to go back down to a min again. Hit enter. Again, to do that, I need again a left bound to start with. So I need to be to the left of that. So that looks pretty good. Hit enter. And then I got to be to the right side of it. And that looks pretty good. Hit enter. Then it says guess, hit enter again, and takes me again to that local minima. So notice how when X equals about 0.71 this time, the min again would be that negative 0.25. So notice how it really is the same min both times. So the relative min is just that negative 0.25. Okay. So let's look at this last one here. So again, I'm going to hit Y equals and hit clear to get that off there. So I need to put this negative 0.4 X cubed. So I hit that X up there. To do cubed, I hit that little, what we call it, the caret of the rooftop. I need a 3. Hit my right arrow. Hit my plus 0.6. I need an X again and squared. Again, if you watch this video over, you can kind of see where those lights are lighting up at over there. Minus then, I'm sorry, let's go back and delete that. I need a plus 3x minus then a 2. So again, my window this time is, my X min is this negative 4. So I type over that, make a negative 4 there, go down. My X max is a 5. That's going to create my interval. Okay. I don't need to change anything else. So now I've got my window. I think all I got to do now is graph it to see what the graph looks like. There's my graph. You kind of see that over here on the left side, there looks like there's a local minima. And on the right-hand side, there looks like there's a local maxima. Let's do the minima first. So again, I hit the second button and hit the trace button to do the calculate button. And I want to do the minima, which is number 3. Hit enter. So to do the left bound, I have to be left of the minima. So I'll move my little cursor over using directional pad and get to the left of it a little bit. Make sure I'm above it. Hit enter. Use my directional pad again and move to the right of it a little bit. Hit enter. Doesn't really matter as long as your bound's in between there. Hit enter again, and you get your values again. So when X equals, so when X equals negative 1.16, the local minima was negative 4.05. So it looks like if I round that to 2 decimal places, that 4 would turn into a 5. So now let's do calculate again, and this time let's look for the max. So second trace does the calculate, and that other was a maximum. So I choose number 4 for the maximum. Hit enter. Now I have to use my directional pad to get to the left bound of it. So stay left of it. That's good. Hit enter. Now I've got to move right of the high point, get where it turns back down again. Hit enter. And then if I hit enter again, it'll guess and give me that minimum or that actual maximum there. So when x equals, looks like 2.16, my maximum this time, my local maximum would be 3.24 or 25. Looks like 25 since that 4 is going to round up. So 3.25 would be the local maximum. So that's how we kind of use the calculator a little bit as well to kind of do these. So let's see if we can make this a little bit bigger, see if there's anything else to do. So now that concludes our lesson. So there's a little bit of a calculator exercise to kind of play with that. So again, we've kind of focused on intervals and a lot of stuff there, didn't we? All right. So you should be able to identify when the function is increasing and decreasing, be able to identify those intervals. Didn't see a whole lot with the constant interval. You probably won't see much on the constant interval in your homework either. And we identified local maximum and minima as well. And remember, they're using the y values to identify those with. All right, I'll stop there and y'all have a good day. Let's see here.